Hi students, it's Mrs. Luther here. It's been a while since we've had a chance to chat. Today we're going to start chapter 10, Solid Geometry. So this chapter is all about 3D figures. By the end of today's lesson, you should be able to classify three-dimensional figures according to their properties, list the parts of those figures, and use nets and cross-sections to analyze three-dimensional figures. So, three-dimensional figures, otherwise known as solids, can be made up of flat or curved surfaces. So notice it's different. Polygons can only have straight sides, and polyhedrons can only have flat surfaces. But solids or three-dimensional figures can have curved ones. They're just not polyhedrons then. Each of the flat surfaces is called a face. So that's kind of a big deal right there. An edge is a segment where two of the faces intersect. So when you draw a prism or a pyramid, the edges are typically the parts where you draw. The faces are kind of the empty space. And then every intersection of three or more faces is called a vertex. So vertex, those are like the corners. Okay. Now, a prism is formed using two bases. They don't have to be the top and the bottom, but often they are, connected with rectangles. You name prisms based upon their bases. So this first one here, there's one of the bases. Here's another one of the bases, and those are triangles. So that is a triangular prism. Now this one, you'll notice rectangle, rectangle. So this is a rectangular prism. And then the next one here, and you'll notice this is a pentagon, and this is a pentagon. So this is called a pentagonal prism. And the next one here, my bases are hexagons. So this is a hexagonal prism. So triangles and rectangles have that suffix "r", so triangular, rectangular. All the rest of them have "ul". So pentagonal, hexagonal, heptagonal, octagonal, all those. Now a cube, I like to say cube because doesn't have a Q in it, is a special prism where all the faces are squares. So every single face is a square, so that's why we call it a cube. All right, now a pyramid is different. A pyramid only has one base and then has triangles. So you'll notice a prism has two bases with rectangles. A pyramid has one base with triangles that meet at a common vertex. Okay? They are also named by their bases. So this one here has a triangle base, so it's a triangular pyramid. This one has a rectangular base, so it's a rectangular pyramid. This one here has a pentagon for a base, so it's a pentagonal pyramid. And then here on the hexagon base is a hexagonal pyramid. And you'll notice both names are important to know. Now a cylinder is special, but it's kind of like, it's very much like a circular prism. So what it is, it's formed by two circles connected with a rectangle. Ask me in class to make you one to show you and to prove it to you. Now a cone is formed with one circle and a curved surface that looks kind of like a triangle with a curve. So the curved surface kind of looks like this a little bit. Okay? that connects to a vertex. Some examples here. Classify each of these figures. Name the vertices, edges, and bases. So this one right here, we're going to say that we know this and that we know all of those are right angles. Okay, so then that would be a cube. So name the vertices. The vertices, if we're going to name them, those are all the points. So here's 1, 2, 3, 4, 5, 6, 7, 8. So we need to name 8 points. So point A, point B, point C, point D, point E, point F, point G, and point H. Notice I have to have the commas if I'm listing points. Without the commas, I've just named an octagon. Okay, edges. The edges are each one of the segments. So I've got segment AB, segment BC. Now you'll notice I draw on my picture as I do it so that I, 1, don't repeat any, and 2, don't miss any. So CD and DA. Now I'll go AE, BF, CG, and DH. And yes, you do need your hats because you're naming segments. And then I've got EF, FG, GH, and HE. And then it says name the bases. So notice that's not the same as faces, okay? So the bases are the ones that it's named off of. So this is named off of a cube, right? So you can pick your 2 bases. It doesn't matter, but they have to be across from each other. So because in this particular instance, all of the faces are squares, you can pick the 2 you want to be the bases, but they do have to be across from each other. So base 1 is square ABFE and square DCGH. Now, I'm not going to go through all of the second one here, but I will kind of quickly say here's your vertices. Okay. Here's your edges. Excuse me. And then you have one base because this is a pyramid and it is pentagon ABCDE. Okay, same thing here. Here's your vertices. Here are your edges. And then there's one hidden back there that you can't see. Excuse me again. Don't lose that one. And then your bases are the top and the bottom triangles. Okay. With this last one, it's a cone. It has one vertex, point N. There are no edges because edges have to be straight lines. And you'll notice there are no straight lines here, so there are no edges. And then the bases, since it's a cone, there's only one, and it is this circle. So we'd have to have a point here, so let's call this A. So your base would be circle A. There you go. We're going to take a break. You go ahead and check over your notes, and then when you're ready, watch the next video.